So one of my pet peeves is, especially with these alligator clips, but with cables in general. You see, I have these two little jumper halves that I hooked onto the supply here. It's live right now, actually, so I'm being kind of dumb, not being careful to move them around. But um, see how they're right next to each other? They could just easily just short together. And it's 3.3, but it's still probably going to deliver a couple amps. What I actually like to do is if I'm going to do something, I'll make it so one of them is much shorter than the other one. So that way when they're moving around, they won't touch each other. So having all of them the same length is really just, you're tempted to do it because it's neat, but it's really not the right way. For safety reasons. And one thing you could do is just tie this one into a knot or a couple of knots, and it would be up here, and that would be much better. So just a word of advice. So now I'm all set up to measure the voltage. It's just another pet peeve of mine is you got a cable here, you got a connector up here, and you got the wire hanging off, and then you got all this weight supported there. I mean, look at how bad that is. It's just gonna freaking break right off, or this is gonna slide off, and it's just terrible. But for measuring something, having it set up like this is bad. But like I always am just such a stickler about mounting stuff down before I work on it, because after you've done all this work, if it moves around and gets messed up, you're gonna be like totally set back. You can see that I tied a knot in that one. That way these are not just like right together. I mean, it still could go up onto the other pins and short, you know. But so this is interesting. Actually, my multimeter is dying, but it's reading 2.3 volts. So I wonder if that is supposed to be that low. Hmm. I'll move it to another orange pin. Like I was saying, I think orange is supposed to be 3.3. Hmm. That one is 2.3 as well. So yeah, maybe my power supply is not regulating well. A lot of times these are set up so that the 5 volts rail is, since most of the power is probably 5 volts, is going to be the rail that is actually responsible for regulating the rest of them. So that is to say, the main control loop on the 5-volt rail is actually responsible for scaling all of the other voltages as well. And those won't regulate too well if the 5 volts not regulated well. And usually power supplies that are set up to regulate of any kind, if they don't have some load on them, they're not going to be totally right spot on. Um, so that's just something to keep in mind. That's probably what's going on here. I'm probably out of regulation because I have like absolutely no load on this, and typically you turn them on and it's loaded with a computer. So that'll be a good project. Actually, I will make a video about making a dummy load for one of these, and maybe we'll make it do something useful. um, so let's see, I put it onto a red pin and it's still 2.3. That's kind of weird. Let's try to see if we can get something similar to 12 out of one of these yellow pins. Nope, 2.3. So something's definitely weird here. I'll have to figure it out. Maybe I overlooked something here, but I'm pretty sure it was working last time I tried. All right, folks, never overlook the obvious. This is not as good of a meter as the Fluke. It's just a fairly inexpensive knockoff current clamp type meter. But it seems to be suggesting that the low battery condition on the Fluke was just making all the voltages look the same, 2.3 volts. Probably the reference voltage inside there was dropping to a really low level or sub threshold on some ADC they have or whatever. But I don't know exactly what was going on. But I set it, and then I was looking for other problems, like it being the loading and stuff like that. It looks like it's actually pretty close right there without much load. And we can check the other voltages too. So I'll do something that I wouldn't typically recommend, but if you're skilled and experienced and you're wearing eye protection, hello, like you should be when you're doing this stuff, you shouldn't be too worried about taking a probe and touching an active circuit. And if I do touch that rail, which was the orange wire there, one of the orange wires, it is about 3.3 volts. So that's in good regulation. And then if I go back here to one of the yellow wires, being careful, I get about 12. So there you have it. That is a nice power supply that you could use for a bunch of different projects with certain precautions. Um, you know, I will say it's not ideal. You can't really get a readout on it, but if you can hook your meter up, or you have a couple of different meters, or you hook up a bunch of ADCs with some appropriate voltage dividers, you can get something that's pretty nice. In fact, that sounds like kind of a nice kit project. Um, Although I'm sure somebody sells one way cheaper than I could ever make. But yeah, so um, that was what I wanted to show you guys about that. And if you have any questions, leave it in the comments, or comments, leave it in the comments. Um, so yeah, I'm going to probably make a little Arduino setup that measures all the different voltages somehow, and we'll see if we can talk about that in the next show. Have a good one. So one other thing, folks. I mean, while I was troubleshooting this, I was saying that, maybe the power supply was out of regulation, that's why the voltage wasn't right, or this or that, even without the multimeter being the issue. A good rule of thumb with power supplies, just because of their nature, is that if something isn't working exactly right, it's probably going to fail really soon. And I can give you a really good example of that. A lot of the power supplies I've worked with before, and even this type of power supply, will have really weird regulation values, really off values, but what's really going on when that's occurring is that some component inside is either failed or is on the verge of failure. And typically power supply components are very high energy. And by that I mean they produce a lot of heat, there's a lot of current, there's a lot of voltage, and there's a lot of power potential in there. So when a component fails, folks, I mean, it can be pretty spectacular. There's a really good reason to wear eye protection with this stuff, and to be very careful. As a matter of fact, where I work, we don't typically turn on any new boards without looking at them with a thermal camera, because then you can see in a matter of seconds that something is heating up inappropriately. Whereas it may take anywhere from seconds to minutes to fail, or even hours sometimes. So really important thing about power supplies to keep in mind is that if they are going to fail, they are probably going to fail pretty spectacularly, and you don't want to be in the way, and you do not want to leave ever any power supply that you think is suspect on and running when you are not around, because there's just way too much stuff that can go wrong with these. I mean, typically capacitors will fail due to high temperature, high ripple current. But like, for example, this, if it was running my computer and the fan failed and there wasn't some fail-safe involved there, this thing would catch your house on fire. I mean, that's the bottom line. There's certainly a number of cases where the power that's necessary to set fire is well below what's required to set a circuit breaker off. So circuit breakers are great insurance, but they are not the whole story. And maybe that would be something to demonstrate here on the show, as well as is the inherent lack of protection on electrical devices, and especially power supplies. I mean, power supplies are just really a gritty part of electronics that a lot of guys I know in engineering who are older say that, oh yeah, when you get old in engineering, they make you build power supplies because, you've been around a long time and you know what you're doing. And I think that's typically pretty true. I mean, power supplies need to be reliable, and they need to be designed right, or they will be unsafe and unreliable, and won't work right. And the trouble is, they'll blow up expensive stuff that you're trying to power if you don't build them right. That's the bottom line. I mean, there's a whole field of inquiry about just what a graceful failure mode for a power supply would be, so it doesn't take everything along with it. So I just wanted to mention that. Be very careful when you're working with power supplies. If you're going to open one of these up, I don't recommend it unless you know what you're doing, or you have somebody who knows what they're doing. And you gotta disconnect it from the power and turn it off for a very long time, for the capacitor's discharge, or can still have dangerous voltage. So please don't take that for granted. Also, be very careful, because even if you turn it off and you know everything's discharged, stuff in there can be extremely hot. And parts, when they fail, we'll do a demonstration, but they typically shatter and pieces fly off of them really fast, and that's shrapnel, and that will go right through you. And I've seen a lot of shrapnel, and it is not fun business to be tangled up with. Might be cool to watch, but you do not want to be in the line of fire So if you're going to do any of this stuff, eye protection, gloves usually is not a bad idea, and hearing protection is good too. But really be careful with power supplies. I can't stress that enough because they are just um, the primal incarnation of electronics, and if they're not right, everything else that is in the system is going to be messed up too. So just my 2 cents on the power supply business.